Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics, and specifically the area of algebra that appears in section 2 of paper 2. We'll be looking at the past paper questions from May 2009 or to 2013. Feel free to like the video and add any comments down below, so we can help you by creating other videos to assist in whatever areas that you are struggling. Don't forget to look at the description down below, where we have outlined the order we suggest to cover all the topics of CSEC Mathematics with all the past paper solutions from May 2009 until the present. Let's look at the 10 major topics in CSEC Mathematics, and we'll be looking at two topics. Topic number 6, Algebra, and topic number 7, Relations, Functions, and Graphs. Both of these topics appear as separate questions in section 1 and as a combined question in section 2. In this video, we'll be looking at the combined question, which is one full question worth 12 marks. This video, the past paper questions appeared every year from 2009 until 2013. May 2009, number 9a, solve the pair of simultaneous equations y equal to 4 minus 2x, and let's label that equation 1, and y is equal to 2x squared minus 3x plus 1, and let's label that equation 2. Let's recall that the first equation is a straight line and the second equation is a quadratic, which means a parabola. So if we're solving this, there are a couple different methods we can use. So I'm going to use the method of substitution. So we're going to substitute into equation 2. So let's write equation 2 first. Y is equal to 2x squared minus 3x plus 1. And from equation 1, we know what y is. So we can rewrite y, replacing y by 4 minus 2x is equal to 2x squared minus 3x plus 1. And let's carry everything across onto the right hand side, so we're left with 0. So 0 is equal to 2x squared minus 3x, and we had minus 2x when we carry it across, it will be plus 2x plus 1, and we had plus 4 on the left hand side, when we bring it across, it will be minus 4. So this simplifies as 0 is equal to 2x squared minus x, or minus 1x, minus 3. If we have a quadratic here, there are a couple different ways we can solve this. We can either use the quadratic formula or we can factorize. Let's try factorizing. If we're doing that, then let's look at the two terms on either end, 2 and 3. 2 3s are 6. So how can we arrange 6 squares? We can put it into a rectangle, 1 by 6. Or we can shift it around and have 2 by 3 rectangle. So one of these pairs we're going to use in order to replace the middle term, which we have underlined in green, which is minus 1. So let's look at it. We can say, can 1 and 6 give us minus 1? Or 2 and 3? Clearly 2 and 3 can give us minus 1. So we're going to manipulate the 2 and 3 until we get the minus 1 by changing the signs in front of them. So plus 2 plus 3, or plus 2 minus 3, or minus 2 plus 3, or minus 2 minus 3. Notice we're playing with the 2 and 3 and we're just changing the signs in front of them in any one of those 4 combinations. And which one of these is going to give us minus 1? Well, the first one, plus 2 plus 3, is not equal to minus 1. That's equal to 5. Plus 2 minus 3 is equal to minus 1, so that's the one we're going to use. But let's work out the others as well. Minus 2 plus 3 is not equal to minus 1, it's equal to plus 1. And minus 2 minus 3 is equal to minus 5. So we're going to use the second pair. So we're going to rewrite it. 0 is equal to 2x squared plus 2x minus 3x minus 3. Because plus 2x minus 3x is equal to minus 1x. And now we can factorize this. Let's underline the first pair, 2x squared plus 2x. If we're going to factorize this, what can we factorize out? We can factorize out the 2x. So we're left with 2x by x plus 1. And let's underline the second pair of terms, minus 3x minus 3. And when we're factorizing that, we want to end up with the same brackets, x plus 1. So what do we take outside? Minus 3. We can write in our final line now, because what's the same in both of them? The brackets. So let's pull it out and write x plus 1. And what's left? Put that in brackets as well, 2x minus 3. And this pair of factors, either one will give us 0. So either the first term, x plus 1 is equal to 0. So x is equal to, let's carry plus 1 across, x is equal to minus 1. Or 2x minus 3 is equal to 0. So 2x is equal to 3, we've got to carry the minus 3 across, so x is equal to 3 over 2. So we have two solutions for x, which means that the straight line meets the curve at two different points, when x is equal to minus 1 and when x is equal to 3. Now we need to find the y values for each term, so we know the exact coordinates when it happens. So let's substitute x is equal to minus 1 into which one of the equations? Equation 1 or 2? Equation 1 looks easier to work with. So let's rewrite equation 1, y is equal to 4 minus 2x. And let's substitute y is equal to 4 minus 2 by minus 1. 2 ones are 2. 2 negatives, same signs, mean a positive. So 4 plus 2, y is equal to 6. So we got the first coordinates of one point of intersection when x is minus 1, y is 6. And let's substitute for x is equal to 3 on 2, using the same format. Y is equal to 4 minus 2x. Y is equal to 4 minus 2 by 3 on 2. And 2 cancels 2, so 4 take away 3 is 1. So the second coordinate would be 3 on 2 by 1. Part B. Express 2x squared minus 3x plus 1, which was this equation 2, in the form a x plus h squared plus k. That means we're completing the square, where a, h, and k are real numbers. So if we're going to equate them, let's write 2x squared minus 3x plus 1 is equal to a brackets x plus h squared plus k. We can see on the left hand side, from a quadratic equation point of view, a is 2, b is minus 3, and c is 1. So on the right hand side, a is the same value, a is equal to 2. And from the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. If we look at the first term and let's extract b on 2a, that's equal to h. So h, which is what we want to find, is equal to b on 2a. And we can just simply substitute. H is equal to minus 3, that's b, over 2 times 2, because we got a already. So h is equal to minus 3/4. And if you want to find k, let's look at what's in the square root, b squared minus 4ac. So let's reverse it. 4ac minus b squared all over 4a. And if we substitute 4 by 2, that's a, which you got already. C is 1, minus b squared minus 3 squared. 4 2s are 8, 8 1s are 8. 8 minus 9. 8 minus 9 is minus 1 over 8. As such, we can write 2x squared minus 3x plus 1 is equal to 2 brackets x minus 3/4 all squared minus 1a. May 2009, number 9C. Using your answer from B above, or otherwise calculate the minimum of 2x squared minus 3x plus 1. Now we just found by completing the square that can be rewritten as 2 brackets x minus 3/4 all squared minus 1/8. So for that to have a minimum value, the smallest value we can get for any term which is being squared is 0. We cannot get a negative term when we're squaring real numbers. If we put x as 3/4, then that whole brackets works out to be 3/4 minus 3/4 is 0. 0 squared is 0. 0 times 2 is 0. So we're left with y is equal to minus 1/8. And that is the minimum value of this function. And part 2 of the question, the value of x for which the minimum occurs, and we just said that x is equal to 3/4. Part D, using your answers from B above or otherwise, calculate the coordinates of the minimum point. And we just got the minimum value to be 3/4, and at that point the y value was minus 1/8. So those are the coordinates of the minimum point. And also, what is the value of the y-intercept? The y-intercept would be the c value. We had ax squared plus bx plus c. So whatever the c value is, That is the point where the function cuts the y-axis, meaning the y-intercept. In this case, it cuts at 1. The values of x where the graph cuts the x-axis. So for us to work this out, we can either factorize as we did before, or we can use the quadratic formula. As we have already used the method of factorizing, let's use the quadratic formula so you can see both methods. So 0 is equal to 2x squared minus 3x plus 1. I've highlighted a as 2 in blue, b as minus 3, and c is plus 1. So when we're substituting, what we're going to get is minus 3 plus or minus square root of minus 3 all squared minus 4 by 2 by plus 1 all over 2a, 2 by 2. So minus minus we works out to be 3 plus or minus the square root of 9 minus 8, which is 1. So the square root of 1 is 1 all over 4. So either x is equal to 3 plus 1 over 4. So x is equal to 1. Because 3 plus 1 is 4, 4 into 4, 1. Or x is equal to 3 minus 1 over 4. 3 minus 1 is 2 over 4. So x is equal to a half. Part E. Sketch on your graph the line which intersects the curve at the values of x and y calculated in A. So let's make a little sketch. We know the curve cuts at the point y equal to 1. We worked it out in part D. And we just saw where it cuts the x-axis at x is equal to a half and x equal to 1. So we know the roots of the equation. So we know 3 points. So let's draw that curve through it. And we know the minimum point, which is worked out, which was identified in part D as the lowest point on the curve, which is 3/4 by minus 1/8. And where does the straight line equation 1 intersect with this equation 2 that we've just plotted? When we draw a line through it, it intersected at minus 1/6. We worked that out in part B. And 3 on 2, 1. May 2009, number 10A. The owner of a shop wishes to buy X guitars and Y violins. To satisfy the demands of his customers, the number of violins must be less than or equal to the number of guitars. Part 1. Write an inequality to represent this information. So since violins are represented by Y, that number of them, and Y must be less than the number of guitars, then we can write it as Y is less than or equal to X. The cost of one guitar is $150 and the cost of one violin is $300. He has $4,500 to spend on the purchase of these instruments. Part 2. Write an inequality to represent this information. So if one guitar costs $150 and we have to buy X guitars, then the price of buying the guitars is 150X plus 300Y for the violins, and that total must be equal to or less than 4,500. And we can rearrange that. So 300Y is less than or equal to minus 150X if I carry it across, plus 4,500. So Y is less than or equal to, let's divide by 300, 0.5X plus 15. And why I rewrote it like this? So it looks like a straight line graph. To get a good bargain, the owner of the shop must buy at least 5 violins. Write an inequality to represent this information. Since the number of violins is represented by Y, then we can say Y must be greater than or equal to 5. May 2009, number 10B. Using a scale of 2 centimeters on the horizontal axis to represent 5 guitars and 2 centimeters on the vertical axis to represent 5 violins, draw the graphs of the lines associated with the 3 inequalities. So let's bring up our graph, and if we consider that each one of those major lines is 2 centimeters away, then we can say 0, 5, 10 onwards. And similarly, if we look on the y-axis, it's the same scale. Y equal to x means a straight line graph. Let's bring it up in black, where it passes through the origin, and when x is 5, y is 5, when x is 10, y is 10, and so forth. You can see it going through all those points. And what do we want? Our first inequality was saying y was less than or equal to x. So that line shows y is equal to x, and if y is less than x, then it means any region below that line will work. If we consider any point on the line, then y is equal to x. At any point below the line, the y value is less than the x value. So that's why we have that arrow indicating that. And let's bring up the second inequality, which was the 150x plus 300y less than or equal to 4,500, which we rearrange. We got y is equal to minus 0.5x plus 15. So that means it's cutting at 15, and the gradient is negative, so it's going down. And when y is equal to 0, x is equal to 30. It says y is equal to that, the red line, or y is less than that, which means that y is below that red line as well. So we have that red arrow going down. So we're showing a region where it's below the black line and below the red line. So it looks like a large triangle right now, starting from 0 to 30 and going up to a height of 10. Our third inequality says y is greater than or equal to 5. So let's draw the line. Each one of these inequalities, when we're drawing the line, we're considering it to be equal. So we say, let's draw the line y equal to 5. That will be, if you go on our y-axis at 5, and we draw a line going across in green, and y is greater than or equal to 5. So y is above that line. So we have a green arrow indicating that it's above that line. Part 2, shade the region on your graph that satisfies all three inequalities. And we can see, let's bring that up as a triangle there to show that in that blue triangle, it's above the green line, it's below the red line, and below the black line. So it fits. State the coordinates of the vertices of the region. Let's bring up the three vertices. The first being on the left, 5, 5. And then the vertice on the right, 25. And the vertice on top, the highest point, where x is 10 and y is 10. Part C. The owner of the shop sells the instruments to make a profit of $60 on each guitar and $100 on each violin. Express the total profit in terms of x and y. So the total profit P is equal to how many guitars are we selling, x amount, and we're making $60 on each one. So the profit will be 60 times x plus 100 times y. The same thinking for violins. Part 2, last part of the question. Calculate the maximum profit. Now the maximum profit, if we look at the triangle in blue, will occur at one of the vertices. Profit is equal to 60x plus 100y. And we can rewrite it using the first point on the left side, where x is 5. We're substituting that, and y is 5. And that will give us 60 by 5 is 300, plus 100 by 5 is 500. That gives us 800. So the profit is $800. If we're considering the point on top, let's substitute p is equal to 60x plus 100y, and we know x is 10, y is 10 at that point. So if we substitute 60 by 10, 600 plus 100 by 10, 1,000. So the profit is $1,600. So the second point, where the second vertice, where it satisfies all three inequalities, shows it makes a profit of $1,600 if we were able to sell 10 guitars and 10 violins, satisfying all three equations. And for the third point, the one on the extreme right, let's substitute profit is equal to 60x plus 10, 100y. And we know x is 20. So if we're able to sell 20 guitars, which satisfies all three equations, and 5 violins. So 20 by 60 is 1200, plus 5 by 100 is 500. So 1200 plus 500 is 1700. As such, this is the maximum of profit occurs, which satisfies all three inequalities. May 2010, number 9a. The diagram below shows the speed time graph of the motion of the athlete during a race. So if we look at our graph, we can see the speed moving from 0 and climbing until it reached 12 meters per second. And then after a while, it started to drop until it went back to 0. Part 1. Using the graph, determine A, the maximum speed. And we can see the maximum speed is 12 meters per second. Part B, the number of seconds for which the speed was constant. And we can see the speed was constant, that flat line up on top, from the time it was 6 seconds until 10 seconds. So 10 take away 6 is 4 seconds. Part C, the total distance covered by the athlete during the race. And in a speed time graph, the easiest way to calculate the distance covered would be the area under the graph. And if we look at that shape is a trapezium. And in our formula sheet, we know the area of a trapezium, which is equal to half a plus b times h, where a and b are the parallel sides. So if we substitute, we get a half times 4, which we worked out in above in part B, 4 seconds, plus the base is 13 seconds, times the height, which is 12. So a half of 12 is 6, 4 plus 13 is 17, 17 times 6 is equal to 102 meters. So that's the total distance covered by the athlete during the race. During which time period of the race was A, the speed of the athlete increasing? The speed of the athlete was increasing from the time of 0 to 6 seconds. Part B, the speed of the athlete decreasing. The athlete's speed decreased from the time of 10 to 13 seconds. And the acceleration of the athlete was 0. This means that the speed was constant. And that happened from 6 to 10 seconds. May 2010, number 9b. A farmer supplies his neighbors with X pumpkins and Y melons daily using the following conditions. First condition, Y is greater than or equal to 3, which means that the number of melons he gives every day is at least 3 melons or even more. Second condition, Y is less than or equal to X. So that means the number of melons he supplies daily is at least equal to X or less than the number of pumpkins. And the third condition, the total number of pumpkins and melons must not exceed 12. So this is a linear programming question. Part 1, write an inequality to represent the third condition. So if we look at the third condition, the total number of pumpkins and melons, so the number of pumpkins is X plus the number of melons is Y. For the most is equal to 12, or it must be less than that. So X plus Y is less than or equal to 12. Part 2, using a scale of 1 centimeter to represent 1 pumpkin on the x-axis and 1 centimeter to represent 1 melon on the y-axis, draw the graphs of the 3 lines associated with the 3 inequalities. So let's bring up the graph. And if our major lines here are 2 centimeters apart, and 1 centimeter represents 1 pumpkin, therefore 2 centimeters will represent 2 pumpkins. And so forth, similarly on the y-axis to represent the melons. And our first inequality, y is greater than or equal to 3. So let's draw the line y is equal to 3. So if we go on our y-axis and we look where 3 is, we draw a horizontal line going across in green. For y to be greater than 3, that means it's going upwards, so we put a green arrow on it to show that line or anything above that line will fulfill the condition. The second condition, y is less than or equal to x, so let's draw the line y is equal to x. And we know if y is equal to x, when y is 0, x is 0. When y is 6, x is 6. When y is 10, x is 10. So we can draw a black line through all. And that's the line y equal to x. If y is less than x, then it means it's coming downwards below that line. And the third condition, x plus y is less than or equal to 12. If we rearrange it, we get y is less than or equal to minus x plus 12. If we're drawing that line, it's cutting at 12. And it's negative, so the gradient is going downwards. We draw that line in red, and if we substitute a value when y is 0, x is 12. So we can draw a line straight through there, and if we're saying y is equal to that or less than that, then the red arrow indicates us going downwards. Part 3. Identify by shading the region which satisfies the 3 inequalities, and it must be above the green line, below the red and black line. So we're seeing a triangle there. Let's put the 3 vertices, let's identify them, and we'll bring up a triangle to show that region, that shaded region. Part 4, determine from your graph the minimum values of x and y which satisfy the equation, and the values out of all 3 is the one on the left hand side. May 2011, number 9a. Solve the pair of simultaneous equations y is equal to x squared minus x plus 3. Let's label that equation 1, which is a quadratic or a parabola. And y is equal to 6 minus 3x, which is a straight line. We'll call that equation 2. So there are a couple of ways to solve this. Let's use substitution. So let's write the quadratic equation y is equal to x squared minus x plus 3. And we know what y is in equation 2. So let's replace y by 6 minus 3x is equal to x squared minus x plus 3. Let's carry everything across, so it'll be equal to 0 on one side. So 0 is equal to x squared minus x. And we had minus 3x when we brought it across, we get plus 3x. plus 3, and we had plus 6. When you bring it across, it will be minus 6. And we can simplify that. 0 is equal to x squared minus 1x plus 3x is equal to plus 2x plus 3 minus 6 is equal to minus 3. So we now have a quadratic, and we can solve this using either factorization or using the quadratic formula. So let's use quadratic formula here. Let's look at the a and c terms. That's 1 by 3 is 3. So if we arrange that, we can only get one rectangle, a 1 by 3 rectangle. So that means that we're going to use 1 and 3 and manipulate it by using plus 1 plus 3, plus 1 minus 3, switch the signs, minus 1 plus 3, minus 1 minus 3. And one of these four terms will give us the middle term that we want, which is plus 2. So if we look at plus 1 plus 3, that's plus 4, so that doesn't give us that. Plus 1 minus 3, that gives us minus 2. And the third one gives us what we want, plus 2. And we can work out the last one. You see that's not equal to plus 2 either. So we're going to replace that middle term by these two terms here using minus 1 and 3. So we get 0 is equal to x squared minus 1x plus 3x minus 3. We can factorize that. Let's underline the first two terms with a maroon color. And if we look at x squared minus 1x, what can we extract? We can factorize out an x. So we're left with x minus 1. And let's look at the next two terms. We underlined in purple 3x minus 3. And we want to extract it, so we're left with the same brackets, x minus 1. So what can we extract? Plus 3. And if we look at that, what's the same in both of them? The brackets, x minus 1. So we can rewrite 0 is equal to x minus 1 by what's remaining, x plus 3. So either x minus 1 is equal to 0, which means x is equal to 1, or x plus 3 is equal to 0, so x is equal to minus 3. We have two solutions, which means that the straight line, equation 2, intersects with the curve, equation 1, at two different points, when x is equal to 1 and x is equal to minus 3. And if we want to solve it, we also need to get their y values. So let's substitute x equal to 1 into the easier of the two equations, equation 2. Let's rewrite the equation, y is equal to 6 minus 3x. And if we substitute, y is equal to 6 minus 3 by 1. 3 ones are 3, 6 minus 3 is 3. So when x is 1, y is 3. So that's the coordinate of one point of intersection. And let's substitute x equal to minus 3. So y equal to 6 minus 3x. So y equal to 6 minus 3 by minus 3. 3 3s are 9. And that's going to give us a plus. So 6 plus 9 is equal to 15. So the second point of intersection is where x is minus 3 and y is 15. Part B, part 1. Express the function f of x equal to 4x squared minus 8x minus 2 in the form ax plus h squared plus k, where a, h, and k are constants. So this is another completing the square method question. So let's write 4x squared minus 8x minus 2. We want to rewrite it as a brackets x plus h squared plus k. So we need to find a, h, and k. And from the left hand side, we know a is 4, b is minus 8, and c is minus 2. So we know a is equal to 4. We already have that. H is equal to b on 2a, which is b is minus 8 over 2 times 4. 2 4s are 8. 8 into 8, 1. So h is equal to minus 1. And k is equal to 4ac minus b squared on 4a. This is a shortcut method to find a, h, and k. And if we substitute, we're going to get 4 by what's a? 4. 4 by minus 2 minus 8 squared. 4 4s are 16, minus 2 is minus 32. Minus 32 take away 64 is minus 96. All over 4 4s are 16. 16 to minus 96 is minus 6. So we can rewrite f of x as 4, open brackets, x minus 1, because h is minus 1, all squared, minus 6. State, part 2, the minimum value of f of x. And if we look at f of x here, to get the least value, then the brackets can work out to be 0. That's the smallest brackets it could be. It cannot be negative. So that leaves us with f of x equal to minus 6. Part 3, the value of x for which f of x is a minimum. In order for that to get a minimum, then the brackets must work out to be 0. X minus 1 is equal to 0. So x is equal to 1. May 2011, number 9C. The speed time graph below, not drawn to scale, showed the 3-stage journey of a racing car over a period of 60 seconds. So if we bring up the graph, we can see that this first stage there is moving from 0 until 12, and it took x seconds. And in the second stage, from x seconds, it remained constant until 25 seconds. And in the third stage, it slowed down from 25 seconds until it stopped at 60 seconds. During the first stage of the journey, the car increased its speed from 0 meters per second to 12 meters per second, as we can see in the graph, in x seconds, accelerating to 0.6 meters per second squared. So we know the acceleration as well. Calculate the value of x. So if we know m, the gradient of the straight line, is change in y over change in x, and the gradient of a straight line in a speed-time graph is also known as the acceleration. So the acceleration, or m, is equal to 0.6, which is equal to change in y, which is the y values change from 0 to 12, so we say 12 minus 0, over delta x, which is x minus 0. So if we simplify, 0.6 is equal to 12 over x, and we can carry the x on top on the left-hand side, and we can bring the 0.6 down, so x is equal to 12 over 0.6, which works out to be 20 seconds. So we found the value of x. Part 2. What is the gradient of the graph during the second stage? Well, if we look at the second stage, the gradient, which is a flat line in this case, and that's also equal to the acceleration, is 0. Explain in one sentence what the car is doing during this stage. During this stage, we can see the acceleration is 0. That does not mean it's not moving. It means that the car is continuing to move, but at a constant speed of 12 meters per second. It's neither increasing its speed nor decreasing, just remaining constant. Part 3, calculate the distance traveled by the car on the third stage of the journey. And if we recall, in a speed-time graph, the distance traveled is the area under the graph. So if we look at the third stage, we want to find the distance traveled there, then we want to find the area of that triangle. A half base times height, S3 is equal to a half times 60 minus 25, that's the base, times the height, which is 12. And we know a half of 12 is 6. 60 minus 25 is 35, 6 times 35. So the distance is 210 meters. And that's the distance traveled in the third stage of this journey. May 2012, number 9a, part 1. Solve the pair of simultaneous equations y is equal to 8 minus x, which is a straight line graph, and let's call that equation 1. And 2x squared plus xy is equal to minus 16, which is equation 2, a curve. So in order to solve this, we can substitute the smaller equation into the larger equation. So let's write equation 2, 2x squared plus xy is equal to minus 16, and we know what y is from equation 1, so we can substitute that, 2x squared plus x by 8 minus x, because that's y from equation 1, equal to minus 16. So let's expand that. 2x squared plus x times 8 is 8x, and x times x is minus x squared is equal to minus 16. And if you want to solve a quadratic, the best way to work it out is put everything across on one side, so on the other side is equal to 0. So let's bring the minus 16 across. So we'll get x squared. So we'll get 2x squared minus x squared is 1x squared plus 8x, and minus 16 becomes plus 16. So we now have a quadratic. So we can solve that quadratic using a couple different methods. Let's use factorization. If we multiply the terms on the end, the a and the c, 1 times 16 is 16. So we can write out a 1 by 16 rectangle, or shift it around and get a 2 by 8 rectangle, or shift it around and get a 4 by 4 square. Which of these terms will give us 8? Easily we can see that the 4 by 4 will give us an 8. So we're going to manipulate 4 and 4 by using plus 4 plus 4, or plus 4 minus 4, or switch the signs, minus 4 plus 4, or minus 4 minus 4. One of these 4 is supposed to give us plus 8. And we can see that the first one, plus 4 is equal to plus 8. And if you work out for any of the others, you can see none of them works out to be plus 8. So we're going to replace the middle term, which I have underlined in green, by two terms, plus 4 plus 4. So let's rewrite that. X squared plus 4x plus 16 is equal to 0. And if we look at the first two terms, x squared plus 4x, we have underlined in maroon. What can we factorize from that? We can take out x. So we're left with x by x plus 4 plus, we want to get the same brackets by the next pair, which we have underlined in maroon, x plus 4, so we take out plus 4. So that gives us x plus 4 by x plus 4. And since it's the same brackets, we can rewrite it as x plus 4 squared is equal to 0. So in order for our bracket squared to be equal to 0, that means the brackets itself is equal to 0. So x plus 4 is equal to 0. which means that x is equal to, carry the plus 4 across, so x is equal to minus 4. Let's substitute x equal to minus 4 into one of the easier equations out of equation 1 and 2. So that'll be equation 1. So let's rewrite that. Y is equal to 8 minus x. So y is equal to 8 minus, brackets, what's x? Minus 4. So 8 minus minus 4, 8 plus 4 is equal to 12. As such, the point of intersection is minus 4, 12. Part 2, state giving reasons for your answer whether the line y equal to 8 minus x is a tangent to the curve 2x squared plus xy minus 16. So if we bring up a curve, and let's consider where a straight line can intersect with it. Let's show that in brown. And we can see if the line intersects the curve there, then there will be 2 points of intersection. And if we bring it down lower in the green line, then there's only 1 point of intersection. And if we bring it even lower, there's no point of intersection. So if we looked at our solution to these pair of simultaneous equations, what we recognized was it cut only at 1 point at minus 4, 12. So there's only 1 point of intersection, so it's only touching there. So the line y equal to 8 minus x is a tangent to the curve as it touches the curve at only 1 point. May 2012, number 9b. A florist makes bouquets of flowers, each consisting of X roses and Y orchids. For each bouquet, she applies the following constraints. Part 1. Write the 3 inequalities for the constraints given. The number of orchids must be at least half the number of roses. So the number of orchids, which is Y, must be equal to or more than half of X, or X on 2. Second condition, there must be at least 2 roses, and number of roses is X, which means X must be equal to or greater than, so we say greater than or equal to 2. And there must be no more than 12 flowers. So if we add up the number of orchids and roses, X plus Y, it must be equal to 12 or not more than that, meaning less than 12. So X plus Y is less than or equal to 12. Part 2, shade the region of the graph which represents the solution set for the inequalities in B part 1. So let's bring up the graph, and the x-axis is represented by X, the roses, and Y, the orchids. And we want to draw a line, first of all, for the first constraint, Y is equal to half X. And let's draw that line in black, meaning that it starts from when X is 0, Y is 0. When X is 4, Y is half of that, 2. When X is 8, Y is half of that, that's 4. When X is 12, Y is 6. So you can see that black line going through there. And what we're saying, that is the line Y is equal to X on 2. Our inequality also says Y is greater than X on 2. So that means anything above the line. We'll indicate that with that arrow. For the second line, X is greater than or equal to 2. So let's go on our x-axis and draw a line at 2 vertically. That's in green. So X is equal to 2 there. But X can also be greater than 2. So it's anything to the right of that. And for our last line, X plus Y is less than or equal to 12. So Y is equal to minus X plus 12. So it's a gradient of a graph which is negative and it's cutting at 12. So let's draw a red line showing that. That line tells us X plus Y is equal to 12, but X plus Y can also be less than 12. So it's anything below that line. X plus Y can be 10, 9, 8, and so forth. Part 3, state the coordinates of the points which represent the vertices of the region where the solution is set. So if we look at that solution there, the solution will be within that triangle, and the coordinates are 2, 1. And if we go straight up vertically, we get 2, 10. And if we move to the right, 8, 4. Those are your 3 vertices of that region. Last part of the question, the florist sells a bouquet of flowers to make a profit of $3 on each rose and $4 on each orchid. Determine the maximum possible profit on the sale of a bouquet. So P is equal to, and that's our profit, 3 times X, because $3 for each rose, plus $4 for each orchid, plus 4Y. And if we substitute for each one of these vertices, one of them will give us our maximum. So P is equal to 3 times 2 plus 4 times 1. That's our first coordinate which we have in part 3. 3 2s are 6, plus 4 1s are 4, 6 and 4 is 10. So the profit is $10. Let's look at the vertice on the right hand side. Let's write our formula. Profit is equal to 3x plus 4y, and if we substitute, P is equal to 3 times 8 plus 4 times 4, and 3 is 24, and 4 4 is 16. 24 and 16 is equal to 40. So we got $40 profit if it occurs on the point on the right side, that vertice. And if we use our top vertice, our highest point, so profit is equal to 3x plus 4y, and if we substitute, P is equal to 3 times 2, x is 2 at that point, and 4 times 10. 4 times are 40, plus 3 2s are 6, 46. So therefore the maximum profit occurs at that point where x is 2 and y is 10. May 2013, number 9A. Trish wishes to buy X oranges and Y mangoes, which she intends to carry in her bag. Her bag has space for only 6 fruits. Write an inequality to represent this information. So if we count the number of oranges, X, and the number of mangoes, Y, X plus Y is equal to 6 or less than 6. To get a good bargain, she must buy at least 2 mangoes. So part 2, write an inequality to represent this information. Now mangoes is represented by Y. So the number of mangoes must be equal to 2 or greater than 2. More information about the number of oranges and mangoes associated with the good bargain is represented by Y is less than or equal to 2x. Part 3, write the information represented by this inequality as a sentence in your own words. So Y, which is the number of mangoes, must be at the most double the number of oranges. So it can be equal to double the number of oranges, or it can be less than that. Part 4, on the graph, draw the lines associated with the two inequalities obtained in part 1 and 2. Let's bring up the graph. And in our first inequality, x plus y is less than or equal to 6. So it's a straight line graph cutting at 6 and cutting the y-axis at 6. So let's draw that line. And that line tells us at any point in time, if we look at any part of that red line, if we add up the x term and the y term, and of course they must be whole numbers, you can't buy half an orange or quarter a mango, then x plus y is equal to 6. But x plus y is less than 6 as well. That's possible because the bag can hold less than 6 fruits. So we indicate that by a red arrow pointing downwards. And in the second inequality, y is greater than or equal to 2. So if we draw the line y is equal to 2, we go on the y-axis and we draw a green line going across, indicating y is equal to 2. Or it can be greater than 2, so we draw a green arrow up, showing us that it's the region on the green line or above will cover that inequality. Part 5. Shade on your graph the region which represents the solution set for 3 inequalities. So we had 2 of the inequalities already sketched. Let's put in the third inequality, and that is that y is less than or equal to 2x. So we're drawing a black line showing that y is equal to 2x, and that line also indicates that y can be less than 2x. So it can also be below that line. We have that indicated anywhere on the right side or below of that black line. So if you want to shade our intersection or region, then that occurs in blue, in that little triangle there. May 2013, number 9B, part 1. Write 3x squared minus 12x plus 8 in the form a, x plus h squared plus k, where a, h, and k are constants. And that means we're looking at completing the square method. Let's rewrite 3x squared minus 12x plus 8 is equal to a, brackets x plus h squared plus k. And we know that quadratic equation a is 3, the term or the coefficient of x squared, b is equal to minus 12, the coefficient of x, and c is 8, where it's cutting the y-axis. So if we want to find a is 3, and from the quadratic formula, if we look at the first term, let's leave out the minus sign, so we're left with b on 2a, that is h. So h is equal to b on 2a, and if we substitute, h is equal to what's b? Minus 12 over 2 times a is 3. 2 3s are 6, 6 into 12 is 2, so h is equal to minus 2. And for k, let's look at the square root term, and let's reverse it. So we get 4ac minus b squared all over 4a. And as we substitute, we're going to get 4 times 3 times 8 minus, what's b? Minus 12 squared. 4 3s are 12, 12 is 96, minus 12 squared is 144. 96 minus 144 is minus 48 over 4 3s are 12. 12 into minus 48 is minus 4. As such, we can rewrite that equation 3x squared minus 12x plus 8 equal to 3, because that's a, by x minus 2, because h is minus 2, squared, minus 4, because that's k. Part 2, sketch the graph of y is equal to 3x squared minus 12x plus 8. That same graph that we just completed, showing on your sketch the intercept of the y-axis. So if we bring up our graph, and where does it intersect? The c value, the value of the y-intercept, is at 8. So let's draw our graph going to the right. The coordinates of the minimum point, we also want to bring that up. The minimum or lowest point of the graph, we have that as a yellow x, and it's indicated that we just worked it out. The minimum point occurs when x minus 2 is 0, so x is equal to 2, and y is minus 4. This brings us to the end of CSEC past paper questions in the topic of algebra and relations and functions and graphs, which occur in section 2. This combined question, we looked at the past paper questions from 2009 until 2013, and in our next video, we'll be looking at the next 5 years from 2014 until 2018. Don't forget to look at the description down below to get an overview of the entire syllabus.